This problem shows how to select heat insulating material for pipes used with high temperature fluids. We will determine the annual savings in heat energy and fuel cost, as well as the efficiency of the insulation used. We will work out this problem in 5 steps. In the first step, we must choose the type and thickness of insulation material to be used. For this particular problem, we will choose calcium silicate as our insulating material. We determine the thickness of the insulation from a table such as the one shown here. In our case, in this problem, the nominal diameter is 10 inches of the pipe, and our operating temperature is 570 degrees Fahrenheit, which lies in this temperature range, and therefore we choose a value of 3 inches for the thickness of the insulation. We also note from a table such as the one shown here for standard pipe dimensions that for a nominal 10-inch diameter pipe, the outer diameter will be 10.75 inches, and we make a note of that. In the second step, we determine the amount of heat that is lost. In order to do that, we need to know 3 things. We need to know the temperature gradient over which the heat loss is occurring, the surface area over which it is occurring, and the thermal conductivity. The temperature gradient in our case is 570 degrees Fahrenheit minus 70 degrees Fahrenheit, so that's 500 degrees Fahrenheit, or in the metric system it's equivalent to 260 degrees Celsius. The surface area of the pipe would be the outside surface. So if this is a pipe, we are going to determine the heat loss over a given surface area, the outside layer. So that would be equal to pi times the outer diameter, that gives us the circumference, times the length that we choose. We will choose a unit length, which is 1 foot, or in the metric system we can choose 1 meter. So that comes to pi times 10.75 inches times we choose a length of 1 foot. So that gives us a surface area of 2.817 square feet per foot length of pipe, or in the metric system it comes to 0.86 square meters per meter length of pipe. We next refer to engineering data handbooks and find that the thermal conductivity for calcium silicate 3-inch thick is 0.200 BTUs per hour per square foot per degree Fahrenheit. In the metric system, the equivalent is 1.14 watts per square meter per degrees Celsius. For the bare pipe, the uninsulated pipe, those same values would be 4.640 BTUs per hour per square feet per degrees Fahrenheit, or in the metric system comes to 26.3 watts per square meter per degrees Celsius. The heat loss through the insulation then would be equal to 0.200 BTUs per hour per square foot per degrees Fahrenheit times 2.817 square feet per foot length of pipe times the temperature gradient of 500 degrees Fahrenheit, and this value comes to 281.7 BTUs per hour per foot length of pipe. In the SI system, the equivalent value would be 254.9 watts per meter length of pipe. For the bare pipe, the pipe without the insulation, the same values come to 6535 BTUs per hour per foot length of pipe, or in the SI system, the equivalent value would be 5880 watts per meter length of pipe. In the third step, we calculate the annual savings in energy, and that is done by determining the difference in the heat loss between the bare pipe and the insulated pipe per unit length per unit time times the total length of the pipe times the total amount of time that it operates in a given year. So this then is equal to the difference in heat loss, which is 6535 minus 281.7 BTUs per unit length per unit time, which is per hour per foot of pipe, times the total length of the pipe, which is 300 feet, times the total amount of time that it operates per year, which is 8,000 hours. And this figure comes to 1.5 times 10 to the 10 BTUs per year. If working in the metric system, this would translate into 15,825.84 gigajoules per year. In the fourth step, we are now in a position to calculate the annual savings in cost, and that would be affected by the boiler efficiency, which is given here as 80%. So the fuel heat savings we saw in the previous step was 1.5 times 10 to the power 10 BTUs per year, and that is modified by the efficiency of the boiler, and that comes to 1.875 times 10 to the power 10 BTUs per year. That in turn allows us to calculate the amount of fuel saved. So we have 1.875 times 10 to the power 10 BTUs per year of savings divided by the amount of BTUs per pound of the fuel, which is 14,000. So it's 14,000 BTUs per pound of fuel available times 2,000 pounds per ton. That's the US ton. And so this comes to 669.64 US tons. If working in the metric system, this translates into 607.5 metric tons. The annual savings can be calculated because we are given the fuel cost, which is $6 per ton, the US ton, times 669.64 US tons, and that figure comes to $4017.86, or approximately $4,018. In the fifth and final step, we determine the efficiency of the insulation that we used, and that would be given by the ratio shown here, which is the ratio of the bare pipe heat loss minus the insulated pipe heat loss divided by the bare pipe heat loss. So those values would come to 6535 minus 281.7 on the numerator divided by 6535 in the denominator. The units cancel out and we get a value of 0.957, that is 95.7% efficiency.